Okay guys, welcome again. I am Daniel Cassandra. I'm going to show you how you can analyze the bending moment as well as the deflection by using ANSYS software. ANSYS, which means analysis and simulation. This was ANSYS version of 2019, which was the second release, so it's release 19.2. So let's take an example that we have a beam. At a front view, maybe the beam looks like this at front view, which means maybe the length from this to this will be equal to 400 millimeter, and the side view of this beam look maybe like this. So the breadth be 20 and the height be that, and this be a concentrated load or point load acting on this. So if it's a point load, will be acting at the center of this beam, and let's assume it is 20 kilonewton, and this be a simple supported beam which is supported at both ends. So if this load is acting at the center of this beam, it means that the length from this point to this will be equal to 20. Half of 400 will be equal to 200. Also at this point will be equal to 200. So in ANSYS, we'll start with preferences, but there is three main steps which we are going to have. The first one is a preprocessor, the second one is solution, and the third one is a general post-processor. So starting with preferences, we have to make sure that the structure is on, because we are going to deal with the structure of the beam. Then at a preprocessor is just inserting the type of the material as well as the material models, material properties. So starting with the element type, we are going to add the types of these materials, which is a beam, and you can select whatever. There is two nodes or whatever, you can select whatever you want. So then you close. Another one, at the preprocessor step, you can add material properties. Here we are going to add material properties such as modulus of elasticity or Young modulus. Then there is Poisson ratio. So at material models, there is a structure. You deal with the structure, linear, elastic, isotropic. Here is modulus of elasticity. So let's take any value, maybe is 290 exponent 9 is a modulus of elasticity. Then Poisson ratio, let's take 0.27. Then you close it. Another step, at preprocessor, we are going to deal with section. Our section here is a beam. At a beam, we will deal with common section. So here you are going to create a section of this beam. So let's take a look at this view, which is side view. We have the breadth, which is 20, then the height is 30. So the same dimension we are going to use here. The breadth is 20, the height is 30. Then we can preview to see how it looks like. So this is 20, this is 30. Then another step, we are going to create a model. But a model here, we are going to create a key points, but in active current section. So here we will have three key points. The first key point at 0, 0, 0, the second one at the point where the load is acting, which is 200, a half of 400, 200, 0, 0, then the last one will be at this point, which is 400, 0, 0. So starting with the first one will be at 0, 0, 0, so you apply it. The second key point will be at 200, 0, 0, then you apply it, and the third one, which is the last one, will be at 400, 0, 0, 0, then you hit OK. Here we have 3 points, which means at this point there is a fixed load, there is a reaction, but a load is acting on this point, which is at the center. So joining this, you use a straight line. So you click lines, straight line, then you can pick this point, also there is this point. You have created a straight line, which means you have joined these key points. Then OK. After modeling, what we are going to deal with is meshing. At meshing, you click mesh tool. Here we are going to deal with lines. So at lines, you can come here, you set, then you can set the division. Click those lines, enter, then number for division or element division. So here you can add any value, maybe let's take 15, then OK. These are division on those lines. Again, repeat mesh tool, then you click here mesh and select those lines, division we have used as 15, then OK. Here we have completed all the steps in preprocessor. So we came at the solution. At this solution, which we are going to deal with, what we are going to deal with is we are going first to define the rods, then we will solve and get those solution, maybe maximum bending moment, and we will see how the deflection will be occurring on this beam. So we will define loads. We will apply structure, displacement, but on key points where there is a fixed point. There is this point, also this point, then you click OK, but it's already growth of freedom, then OK. Again, what we are going to have is force or moment, because we see here there is a load which is acting at the center of this beam. So how we add it, we came at the force or moment, but on key points, then we can direct, which is at this point, then OK. But if you see at this sketch, the force is acting downward, but it is in y direction. So we'll deal with y direction here. You change it and make it y, fy, but the value here is 20 kilonewton. So but because it's acting downward, it will be negative 20 kilonewton, which is equal to 20,000 newton, then OK. So here you see the load will be acting downward at this point. Here is fixed, there is a reaction, here there is a reaction. After applying and defining the roads, we came up with solving. So we solved current line section. So here the solution is done. You can see solution is done. Then you click OK and you can close this one. So coming at the plot control, you can view the styles, the shape. You can make the shape be visible as it is. If it's in 3D, then you can click OK. This is our beam. You can view it in isometric view. It looks like this. So the load will be acting at this point. This is a fixed point, this is a fixed point. Or you can view it in front view, whatever you want. So we came the last step, which is general processor. Then we can put that. You can put that. Then here there is a deformed shape or undeformed shape. You can click OK. So you see how after applying the load, how deflection will be at this beam. So it looks like this. So once you apply 20 kilonewton load at the center of a 30 beam, the beam will deflect like this. You can animate and see how it's looking. So at plot control, you can come at animate and then deformed shape, deformed and undeformed, then OK. And you see how the beam will be deflecting. So this is deflection. You can stop it. So you can stop. This is maximum deflection of a such beam when it is fixed at this end, and the rod is acting at the center of a such beam. You can view it even in OK. So you can view it in isometric view, and also you can animate it how it looks like, deformed shape. OK. Then this is how it will be deflecting. Now OK, thank you guys. Don't forget to subscribe on my YouTube channel for more tutorials, and you can ask by commenting below.